Hello, welcome to my channel. Before proceeding to study, please subscribe to my channel. Today, we will explore the fascinating world of basic electrical and electronics engineering. We'll dive into key concepts like concept of phasor, concept of power factor, concept of impedance, and admittance, active, reactive and apparent power. Slide 1. Concept of phasor. Let's begin by understanding what a phasor is. A phasor is a way to represent sinusoidal alternating current or voltage as a rotating vector in a complex plane. Instead of working with sine and cosine functions every time, we simplify them by converting them into vectors that rotate at a constant angular speed. This helps make AC analysis easier. A phasor shows the amplitude and phase angle of the waveform, which tells us how much voltage or current is there and how early or late it is with respect to another waveform. For example, if a voltage is given by V of t equals 100 sin omega t, the corresponding phasor would be V equals 100 angle 0 degrees. This means the voltage has an amplitude of 100 and a phase angle of 0. Phasors are useful because they allow us to work with steady-state sinusoidal signals using algebra instead of differential equations. This makes analysis much faster and more manageable, especially in complex circuits. In phasor diagrams, different waveforms like voltage and current can be plotted with arrows showing their relative angles, helping us visualize lead or lag conditions in AC circuits. Slide 2. Concept of power factor. Power factor is a very important concept in AC circuits. It tells us how efficiently electrical power is being used in a system. Technically, power factor is the cosine of the phase angle between the voltage and the current in a circuit. The formula is power factor equals real power divided by apparent power, or PF equals P divided by S. Real power, or active power, is the power that actually does useful work, like turning a motor or lighting a bulb. Apparent power is the total power supplied, which includes both useful and non-useful power. If the power factor is 1, it means all the supplied power is being used efficiently. But if the power factor is low, it means a lot of power is being wasted in the form of reactive power. For example, in a pure resistive circuit, power factor is 1. In inductive circuits like motors, current lags voltage and power factor is less than 1. Power factor is crucial in industries because a low power factor leads to higher current, more losses, and larger electricity bills. It can be improved by using power factor correction devices like capacitors or synchronous condensers, which help bring the power factor closer to 1. Slide 3. Concept of impedance and admittance. Impedance is the total opposition that an AC current faces in a circuit. It includes both resistance and reactance. The formula for impedance is Z equals R plus JX, where R is resistance and X is reactance. The symbol J represents the imaginary unit. Impedance is measured in ohms, just like resistance, but unlike resistance, it is a complex number with both magnitude and phase. Reactance is of two types: inductive reactance, caused by inductors, and capacitive reactance, caused by capacitors. These affect the phase of the current with respect to voltage. Admittance is the reciprocal of impedance. It tells how easily current flows in a circuit. The formula is Y equals 1 divided by Z. Admittance is measured in Siemens. It also has two parts: conductance, real part, and susceptance, imaginary part. Y equals G plus JB, where G is conductance and B is susceptance. Example: if a circuit has impedance Z equals 4 plus J3 ohms, then admittance Y equals 1 divided by 4 plus J3, which can be calculated using complex number division. Impedance is useful when analyzing series circuits. Admittance is more useful when dealing with parallel circuits. These concepts help us accurately model and solve AC circuits. Slide 4. Active, reactive and apparent power. In AC circuits, power has three components: active, reactive, and apparent power. Active power, also called real power or true power, is the actual power consumed by devices to perform work. It is measured in watts. Reactive power is the power that flows back and forth between the source and reactive components like inductors and capacitors. It does not do useful work but is necessary to maintain electric and magnetic fields. It is measured in volt-ampere reactive or var. Apparent power is the product of total voltage and current without considering the phase angle. It is measured in volt-ampere or VA. The relationships are S equals V multiplied by I, apparent power. P equals V multiplied by I multiplied by cosine theta, active power. Q equals V multiplied by I multiplied by sine theta, reactive power. These powers form a right-angled triangle called the power triangle, where apparent power is the hypotenuse, active power is the base, and reactive power is the perpendicular. Example: if V equals 230 volts, I equals 5 amperes, and power factor is 0.8, then P equals 230 multiplied by 5 multiplied by 0.8 equals 920 watts. S equals 230 multiplied by 5 equals 1150 VA. Q equals square root of S squared minus P squared equals 690 var approximately. Understanding these types of power helps engineers design efficient power systems and manage energy use effectively. Slide 5: Differences: impedance versus resistance, admittance versus conductance. Let's compare impedance and resistance first. 1. Resistance is the opposition to current in both DC and AC circuits. Impedance only applies to AC circuits. 2. Resistance is a scalar quantity. Impedance is a complex quantity with both magnitude and phase. 3. Resistance only has a real part. Impedance includes both resistance and reactance. 4. Resistance remains constant regardless of frequency. Impedance varies with frequency due to reactance. 5. Resistance is measured in ohms. Impedance is also measured in ohms but represented as complex numbers. 6. Resistance consumes power. Reactance, in impedance, stores and releases power. 7. Resistance is used for both analysis and heating effects. Impedance is mainly used in AC analysis. 8. Impedance is used in phasor and frequency domain analysis. 9. Resistance has no angle. Impedance has a phase angle. Now comparing admittance and conductance. 1. Conductance is the reciprocal of resistance. Admittance is the reciprocal of impedance. 2. Conductance is a scalar. Admittance is a complex number. 3. Conductance equals 1 divided by R, admittance equals 1 divided by Z. 4. Conductance only has a real part, admittance includes both conductance and susceptance. 5. Conductance is measured in Siemens, admittance is also measured in Siemens but has a real and imaginary part. 6. Conductance is used for DC analysis, admittance is useful in AC parallel circuits. 7. Admittance simplifies calculations in parallel AC circuits. 8. Conductance does not vary with frequency, admittance can vary due to susceptance. 9. Conductance is used to express ease of current flow in resistors, admittance does the same for general AC elements.